Okay, to finish out this chapter, we're now going to talk about the sampling distribution of the proportion. So up to this point, we've been talking about the average. So we were trying to estimate the population parameters mu and sigma squared. But now we're interested in the population proportion. So now when we think about our population, so this big circle, we're now talking about the population proportion pi and the number of observations in the population. And to get estimates for those, we're going to calculate our sample statistics. So we take a sample of size n, and we calculate a sample proportion p from that. And that'll be our guess or our point estimate for pi. So our population proportion is represented by pi, and it's just the number of successes out of the total number of observations. Whereas the sample proportion p is the number of successes out of the n sample or n observations in our sample. So the process is very similar to what we've talked about before. So again, we take repeated samples and we calculate our sample statistic p for each of those samples. We then average all of those p's, and that will be our estimate for pi. So we can say that p is an unbiased estimator for pi. So just as x bar was an unbiased estimator for mu, p is an unbiased estimator for pi. And then finally, when we calculate the sample or the standard deviation of p, so sigma p, we're going to use this formula, which is the square root of pi 1 minus pi divided by n. So we can think of this as a binomial random variable, if you can recall what the binomial random variable was, which was that x is just the number of successes out of n trials. And so all p is, what we're measuring now, is just the number of successes out of those n trials. So it's the proportion of successes. So we're interested in the proportion of successes in the population. Our guess for that will be the proportion of successes in our sample. So if we wanted to think about this, we might think about the proportion of people who are left-handed in the US. So pi would be the true proportion of people who are left-handed in the US. N would be the number of people in the US. And then if we took a sample, p would be the proportion of people who are left-handed in our sample. And of course, our sample size would be size n. So we also need to think about, again, how is x distributed? And we've just got a very simple rule. We're going to say if n pi, so the number of observations in the sample times the proportion is greater than 5, greater than or equal to 5, and n times the proportion of failures, so 1 minus pi, if that is also greater than 5, then we're going to say that p is normally distributed. And to put it more succinctly again, so p will be normally distributed with a mean of pi and standard or variance of sigma squared p. So if we want to calculate z-scores, just like we did for x bar, so z-scores for p, we're going to have z is equal to our sample proportion minus the population proportion divided by our standard deviation of p. So plugging in our formula for standard deviation of p, we then get this formula right here. Okay, so let's do an example. A bank determines that 40% of its customers have multiple accounts at the bank. What is the probability of finding a sample proportion of less than 0.3 from a sample of 200 customers? Okay, well, let's note a couple of things. First off, sample is equal to 200. We are interested in a proportion of 0.3, and we are suggesting that pi is equal to 0.4. Because our population here is customers at the bank, so customers who are at this bank, and they have determined that 40% of them have multiple accounts out at the bank. Now, whenever we take a sample, we're interested in finding the sample proportion less than 0.3. So that's why I am calling p 0.3 because we're saying that's the proportion from the sample, and I'm calling pi 0.4 because that suggests That is the proportion of customers at the bank in total. Okay, so what are we asked here? We want to know what's the probability of finding a proportion less than 0.3. So let me rewrite this. Probability that P is less than 0.3. So before we calculate our z-score for this, let's just first check our assumption. So recall that we need n pi. So in this case, that's going to be 200 times 0.4 is equal to 80, which is bigger than 5. And then n1 minus pi will be 200 times 0.6, and that'll be equal to 120, which is also bigger than or equal to 5. So if we just want to give this a check mark, so check, check, we're good to go. We've met our assumptions. So we're now ready to calculate our z-score. So we have p less than 30. So I'm going to say this is equal to p, our probability, z, less than, and now we're just going to use our formula, this one right up here. I'm going to apply this formula right here. So I'm going to take p is 0.3 minus pi 0.4. Actually, let me just go ahead and copy this down here so we can see it. All we're doing is plugging into this formula. So p was 0.3, pi was 0.4. So now divide by the square root of, let's see, 0.4 times 1 minus 0.4, or 0.6, divide by n is 200. So this is going to be equal to the probability that z is less than. If we plug this into our calculator, we're going to get z less than negative 2.89. Okay, so now we need to look up this probability. So let's, as usual, draw this. So we have a negative, so it's to the left of 0, so negative 2.79. We are interested z less than negative 2. I wrote 89, 2.89. So we are interested in this area right here. So we have a negative value, so I'm going to go ahead and use our negative table. So that is this value. So I have the value negative 2.89, and I'm interested in this area. So let's just go ahead and look that up. So negative 2.8, so negative 2.8, and then 9. So that's going to be the very last column. So negative 2.89. So we get 0.0019. So this area is 0.0019. So our answer to this question is 0.0019.